Yeah, here it is, 9, right? So if we're gonna we start by um here. I'm not sure. I haven't actually read what I wrote here. I wrote it years ago. But if I were to do it now, um, I would say we need to make a story about what Pooh Bear does and about what I had the slides. I think I didn't save it because the slides were so yicky. But um, so imagine that on the playing field is the do you understand? Do you get what the problem is? It's the middle third,
Yeah, yeah.
right? So the there imagine down that you're Pooh Bear and you're standing on a hill, or maybe you're walking. Yeah, let's have you on a hill orchestrating the whole thing. And the DFA that you're given is laying on a field below you, right? And and what does that mean is that there's these dots, which are the states, and there's these roads between the states, and there's these road signs telling you how to get from one road if you're on a dot, there's a road sign that says if you get an A, go this way, right? And um and the announcer is announcing the middle third, right?
Hmm.
And you have a fairy godmother who will give you information whenever you want it. So
Would the announcer only announce the middle third or the entire sequence?
no, it's he announces your input, and your input's the middle third, right?
So they wouldn't need to, I mean, we wouldn't need to count the number of characters at first and find
Yeah,
where the
well,
middle
you're
third
you're
starts.
you're going to need to, but that's the tricky thing, right? You're only being given the middle third, and you need to know um right, what is the first third, what is the last third, are they the same size, right? And do they
Hmm.
connect together to form a string that's accepted by the DFA that's on the field below you?
Yeah, but I don't understand how the broadcaster can just tell us where the middle third is.
Can't. That's why we need he's just going to announce the middle third. All right, so let's let's try to make up a story here. The fairy godmother, um, even before you start, right? She knows the entire middle third, right? Because she knows the input before it starts, right? And so she's really smart, so she can figure out what the first third and what the last third are, right? So the fairy godmother knows the entire input, and she knows what the thirds are, and she knows, and it's a yes instance because she helps us with yes instances. So there is this third. Um, And so what she does is she runs the entire the entire input, the three parts. She runs that entire input on the DFA that's on the ground below you, and and she figures out what state um, the machine will be in. At the beginning of the first third, clearly it's going to be on the start state. On the beginning of the second third, there's going to be some state that it's in. And what she does is she puts we're going to have 5 friends, all right, that are going to help us.
Yeah.
And she puts one of the friends on the start state, and she puts 2 of the friends on the state that the machine will be when it's starting the middle third. And she puts 2 friends on the state starting where on the state that will start the last third, right? Does that make sense?
Yeah, yeah.
All right, so that's the beginning of, right? That starts it off. We know where these thirds are going to begin. Now, why did we put two friends on the beginning of the second and third thirds? Is because one friend is acting like breadcrumbs. In fact, maybe it doesn't need to be a friend. We could put one friend and a pile of breadcrumbs on that on those states. The reason breadcrumbs is because they're not going to move. They're just there so that we remember where they are. Right? We're going to remember, we have to check to make sure the fairy godmother's not lying to us.
Yeah.
Right? So now the Pooh Bear. Let's state first what we want him to do, and then we'll state how he manages to do it. All right. What he wants to do is, remember, here's my fingers. This guy's on the start state. This guy's on the first third. This guy's on the second third. And at the very end is some state which is an accept state, but we'll know accept states when we get to it, so we don't have to mark. What we want him to do is every time the announcer announces a character, he wants to move the three friends forward by one step along the path, right? So he moves them along the path. And so as he does that, they come along the path. And now when the third is done, right, if they're all the same length, right, the first third and the second third and the third third are the same length, what will happen when those thirds are done? The guy who was at the beginning will get to the second guy, and the guy who is the second guy will get to the third guy, and the third guy will get to an accept state, right? And when that happens, then Pooh Bear rejoices and accepts. Why? Because they've traced out a path for the entire input, right? Mm-hmm. Because he knows now that there's a path from the first guy to the second guy, which continues on to the third guy, which continues on to an accept state, right?
Yeah.
And he made sure that the middle third followed the announcer, right? So he knows that the middle third, he knows that what he can conclude from that is that what the announcer announces is the middle third of some path that has the thirds are at the right length, and it travels from the start state all the way to an accept state, right? So he now knows that the middle third is a middle third, and he will accept it. Right? Does that make sense?
Yep. So how many states would we require?
Right, we're going to get to that in a minute. What we haven't yet said is how Pooh Bear achieves what we said. Pooh Bear needs to shift everybody ahead by one, right?
Yeah.
So how does he do it? Let's talk first about the guy who's going through the middle third. He has no problems whatsoever. Why? Because he is standing on some state. The announcer announces the character, and he just follows that character, right? Mm-hmm. So the middle third guy is not having a problem. But what about the first third guy? He's on the start state. He needs to be following the right path, right? But he doesn't know what the characters are, right? Pooh Bear doesn't know what the characters are. The guy in the field doesn't know what the characters are. It's right? He needs to be following the first third, which who knows the first third? Who knows what the characters are of the first
The
third?
fairy godmother.
Fairy godmother, right? So the fairy godmother is going to push the first third guy every time step. She will push the first third guy along the path, and she will push the last third guy along the right path. And so what is Pooh Bear checking? The Pooh Bear's checking that there is a path of the right length, right? He's just making sure that the fairy godmother is pushing him, those guys along a path, which will eventually, in the right time steps, meet up with the other guys, right?
Yeah.
Does that make sense?
Yeah.
All right, so then you ask, how many states are there? Well, suppose the original DFA has capital Q states, right? Capital because little q is used for a particular state. Then what is written on Pooh Bear's blackboard? Well, he has to remember the location of all 5 of his friends,
Yeah.
right? So how many states does he have?
Well, friend 4 and 5 wouldn't change its states,
But they're still written on the blackboard.
but they would only be considered 2 states, right? For 4 and 5. 1, 2, and 3 would be the ones moving, which would be changing states.
Yeah, but all 5 of them need to be written on the blackboard, right? Because why do we have we need the ones who don't move need to be written there so that Pooh Bear can verify that when they meet up, right? We only when do we accept, right? We accept when the moving guys meet up with the stationary guys.
Mm-hmm.
So that needs to be written on the blackboard.
Yeah. So would it be the length of the characters divided by 3?
No, focus on what's written on the blackboard.
What's written on the blackboard?
Yeah, what is written on the blackboard?
The positions are in.
The 5 states, right? The 5 states.
Yeah.
So how many possible, we need to know how many different things could be written on the blackboard. Right? How many, I mean, one way of thinking about it is bits. How many bits does it take to write down the name of a state? They're Q states in the original DFA, right?
Yep.
And so you have to give each one a name. How many bits does it take to write down one of their names?
2 to the Q.
Opposite direction. Log Q.
Oh, right.
They're Q different values. Then if you have a log Q bits, right? Then they're Q different log Q bits, log Q strings.
Yeah.
Right? So it takes log Q to write down the name. So how many bits do I need to write on the blackboard?
Sorry, Professor, I'm not really getting it.
All right. So you have a blackboard here, and you have to write down 5 names of states on the blackboard, right?
Yeah.
Just the blackboard, and you're writing down the names, right? And we just said to write down the name of one of the states takes how many bits?
Log 2 to the 1.
Log Q bits.
Yep.
Right? How many bits does it take to write down the second name? Log q bits,
Mm-hmm.
right? And there are 5 of them. 5 names.
So it's still log qubits.
Each of them takes log q bits.
Yeah.
And there are 5 of them. So how
So
many are written on the blackboard?
that to the power of 5.
No. I mean, clear your mind of fancy math and just and pretend you're in kindergarten. I'm writing log q bits and then log q bits and then log q bits. What's the total number of bits I write down?
5 log qubits.
But yeah, 5 times log q, right?
Yep.
So now we're going to have to do, now we have to go back to university and do some math. If the total number of bits I write down is 5 times log q, then how many states are there? How many ways is there to fill in bits for 5 when the total number of bits is 5 log q? Then how many different ways are there to do that? Let's say capital R equals 5 log q. Now I have an R bit string. If I have an R bit string, how many R bit strings are there? How many, if I have I have an R bit string, how many choices are for the first bit?
2.
And how many choices for the second bit?
2.
So how many ways are me to choose an R bit string?
2 to the R.
2 to the R, exactly, right? So I'm going to need 2 to the R states, right? Each of them with a different R bit string,
Yep.
right? So R, remember R was 5 times log Q.
Yeah.
So the number of states we need is 2 to the 5 log Q.
Yep.
Can you figure out how to bring the Q to put that into a more normal form? Can you bring the Q down? Do you know what I mean by that?
Um